Welcome to The Explainer. Today we are going to tackle a huge topic in the world of software, Object-Oriented Programming, or OOP. It's a really foundational concept, and it powers so much of the tech that we use every single day.
So what do building a car and writing code have in common? I know, it sounds a little weird, right? But the answer to this question actually unlocks one of the most powerful and, honestly, intuitive ideas in all of modern programming. It's all about how we decide to build things. Okay, let's dive in.
You know, for the longest time, programming was basically like following a recipe. A very, very long recipe. You had a list of instructions, you followed them from top to bottom, and that was it. We call that procedural programming. And it works, but as programs got more and more complex, think building a whole city instead of just one house, these long lists of instructions became a real tangled mess. OOP came along and offered a totally new way of thinking. It shifted the focus away from the steps and onto the things the steps were for. These things we call objects.
And this is where the genius of OOP really shines. It encourages us to think about our code in the exact same way we already think about the real world. So to make this absolutely crystal clear, we're not going to talk about abstract stuff. No, we are going to build a car right here from the blueprint all the way to the finished product.
All right, first things first. You can't just start welding pieces of metal together and hope a car pops out, right? You need a plan, a master design. So in the world of OOP, that master plan is called a class. The class is the blueprint. It's not a specific car you can drive, but it defines everything that any car made from this design will have. You know, properties like a make and a model, and everything it has to be able to do, like start and stop.
Okay, but a blueprint isn't a car, right? You can't drive a blueprint to work. For that, you need an actual physical car. And in OOP, that car is the object. It's a specific, concrete instance created from that class blueprint. So while the blueprint is general, the objects are the real deal. This is a blue 2023 Toyota. That one is a red 2024 Honda. Same design, but with their own unique details. And this is just a perfect illustration of the creation process, which programmers call instantiation. It's so cool. You take your car class, the blueprint, you tell the factory to fire up the assembly line, often with a keyword that's literally called new, and boom, a brand new, unique car object rolls off the line, ready to go.
Okay, so we've got our shiny new car. It's an object. But think about this for a second. You wouldn't want just anybody to be able to walk up, pop the hood, and start yanking wires out of your engine while you're driving, would you? Of course not. That would be total chaos.
And that, right there, is the whole idea behind a core OOP concept called encapsulation. It's like building a protective case around the important internal workings of your object. You bundle its data, the engine parts, together with the code that actually uses that data, and then you put up a wall to restrict who can mess with it directly.
And the way we do this is actually pretty clever. We label our data. The really sensitive internal stuff, like the engine's timing, the fuel injection system, we mark all of that as private. Nobody from the outside can touch it. But the controls we want the driver to use, the steering wheel, the gas pedal, the brakes, we mark those as public. It creates a safe, predictable, and clear interface to drive the car.
These public controls, well, programmers have a simple name for them: getters and setters. A getter lets you safely get or read information. Think about looking at your speedometer. That's a getter. A setter lets you safely set or change the car's state, like when you press the gas pedal. You aren't directly messing with the engine. You're using the safe public pedal to tell the car what you want it to do.
All right, let's think about that assembly line again. When a brand new car rolls off, it's not just a dead pile of metal. It has to be put into a valid, ready-to-use state. You know, the engine needs oil, the tires need air. It has to be ready for you to turn the key. So in OOP, that whole turnkey setup process, that's handled by a special method. It's called a constructor, and you can always spot it because it has the exact same name as the class. The very moment a new object is created, the constructor just runs, automatically, setting up all the initial values and making sure the object is born in a healthy, usable state. And just like when you're buying a real car, you've got options here. You can use what's called a default constructor. That's kind of like getting the standard base model right off the lot. Or you can use a parameterized constructor. This is where you specify all the details right up front. I want a Ford Mustang from 1969 in black. You provide the parameters, and the car is built to your exact specs from the get-go.
Okay, wow. We've designed a blueprint, we've built the car, we've protected its engine, we even gave it an ignition switch. It's a great analogy, sure, but why? Why go through all this trouble? What's the real-world payoff here?
Well, this is why it matters. This is the payoff. Your code becomes modular. A complex traffic simulation just becomes a bunch of simple, independent cars. It's reusable. That same car blueprint can make one car or a million. And it is so much easier to maintain. If you find a flaw in the engine design, you don't have to fix a million individual cars. You just fix the central blueprint, and every new car built from then on is better. The bottom line is this. OOP isn't just about being tidy. It's about building strong, flexible software that can grow and change without collapsing under its own weight.
You see, this whole way of thinking, seeing the world and our code as a collection of objects that talk to each other, it's been a total game changer. It's the foundation for everything from your phone's operating system to massive online worlds. It is an incredibly powerful way to manage complexity. And that leaves us with one final thought. With these fundamental building blocks, these digital Legos, what new and incredible realities will we construct next?